The objective in today's lesson is we're going to work our way backwards, meaning I'm going to give you what the answers are for a quadratic equation, and you're going to give me an equation. So to get a little bit of better understanding of what we're talking about doing, let's do what we've done before, which is work our way forwards. So I ask you to solve the following quadratic equation. Hopefully you're seeing that this is an IM equation. You set each factor equal to 0. And you get your two answers. Now, what we're going to do today is I'm going to give you the 4 and the 3 and the negative 3, and you're going to give me that particular equation. All right? And you're going to see how it's similar when we talk IM in terms of what we're doing. So what is a root? A root is the solution or solutions to a quadratic equation. Now, there's two ways we can write a quadratic equation, all right? Two methods. I'm going to let you choose which one you like to do. The first one is, you'll see, very similar to doing IM, which is what we're going to do is find the sum of the two numbers, and then the product of the two numbers. And then this is where you've got to be careful, and this is why this method is a little bit tricky. You write your answer as ax squared minus the sum of x times x plus the product equals 0. What's tricky about it is you have to change whatever you get as the sum, you have to change that sign. You multiply by the least common denominator to eliminate any fractions. Okay, so that's method 1. And when we go through an example, I'll show you the first example using both methods. Now, method 2 is we work backwards to write the two binomials that resulted in the roots. We multiply the binomials to get the quadratic equation. Don't forget to set it equal to 0. And then again, we're going to multiply by the LCD to eliminate any fractions. All right, so let's go through a couple of examples. We want to write the quadratic equation given these roots. So let's do method 1 here first. I add the 2. 2 plus negative 5 and get negative 3. I multiply the 2, get negative 10. And then this is where you got to be careful, because your answer is x squared plus 3x minus 10 equals 0. Method 2, if my answers were x equals 2 and x equals negative 5, then right before that I had x minus 2 and x plus 5. I FOIL that. I'm going to set that equal to 0. Please don't forget to do that. And then I get my answer. Again, I don't have a preference as to which of these two you use. Just make sure you use one or the other. Okay? Write the quadratic equation given the roots 0 and negative 6. Okay? I'm just going to use method 1. I'm going to interchange using these methods. So, if this is the case, that means my C is 0, and that's how I get my answer. Okay? All right? And then the next example, one thing to point out, there actually is an infinite number of equations you can come up with. Because when you come up with your equation, if you multiply it by a constant, it's still the same equation. All right. So now I'm going to show you using method 2. I FOIL this at x squared plus 2x minus 1/3 x and minus 2/3. So now this is where we want to get rid of these fractions. So I multiply by my LCD. What's my LCD? It's 3. So you multiply everything by 3. So I get some very nice numbers to work with. Okay? And then I just combine my like terms at the end. Okay. All right? Now, more to my point. Using the equation from example 1. Okay? So let's go back to our equation from example 1, which was x squared plus 3x minus 10 equals 0. Write another equation with the same roots. Okay? Well, very simply, I could just multiply this by any constant. And these two equations, the one in green and the one in red, are the same equation. In other words, they have the same root. So my conclusion, if you multiply each term by a constant, and remember, it's set equal to 0, so that doesn't change. The roots are the same. Okay? However, the graph has a different vertex. Same axis of symmetry. Okay? Okay, and then number 5, using the same equation from example 1, write another equation with the same roots that opens downward. So what would I simply do here? Multiply it by some negative. Just choose -1. So this is the graph that would open downward. Okay? All right. Now, just to shift things a little bit, I want to write the equation of this parabola. So first thing is you should see your roots are x equals -1 and x equals 5. So I'm going to FOIL this out and get x squared minus 4x minus 5 equals 0. Now the question is, does that have this vertex? So check it. And you can check this on your calculator, but let's just do it by hand. X equals -b over 2a. And yes, my vertex is 2, which is the vertex here. So this equation mirrors this. Okay? And then the next example, write the quadratic equation based upon this graph below. So you see your two roots. I FOIL this out. Now, let's go to the graphing calculator. And let me just pull that up for a moment. And if I put in this equation into my graphing calculator, what I want to do is check that my vertex is 5, 8. Okay? Now, and I'll do one other thing before that. While the graphing calculator is coming up. Should have had that loaded beforehand, but best laid plans. Alright, so let's just quit out of this for a moment. Let me just minimize that. Now, this opens downward, so I want to multiply everything here by -1. So I'm going to put in this equation into my calculator, and let's see if I end up with a vertex of 5, 8. Okay? So negative x squared plus 10x minus 21 And then I'm going to go second graph. And now if you look here, when x is 5, which is the axis of symmetry, y is 4, while they have 5, 8. So in order to make this work, I need to double these numbers so as to shift my graph. Okay? So to just recap what we did today is we wrote the equation, a quadratic equation, given the roots, or given the graph which gives us the roots.